Hey there, stats enthusiasts. Welcome to the last video in our series on Unit 9 in AP Statistics. Unit 9 has been all about inference for regression slope, and now we are in our final video for this unit, and in fact, the final content video for the entire course, where we're going to be talking about computer output and calculator commands, specifically the TI-84s that we use, and talking about them in relation to hypothesis testing and confidence intervals for our slope. If you're ready to watch this video, go ahead and grab the notes that you have, and we will go through the content together. First, we're going to talk about computer output. So as I've been saying, for most problems, you don't have to calculate all the values from scratch in an inference procedure. Usually you are given the values and graphs in the problem. And a lot of the times, the AP exam will format to a specific technology output. And that's what I want to show you what that output usually looks like. So this output was created, it comes from notes 1, where X represents our teacher salary and Y represents the amount of money we spend per student, or the amount of money a school district spent per student. So we have seen this computer output before back in Unit 2, but now we're going to have some more information about it. So we have our headers here. It says predictor, COEF, SE, COEF, T, and P. So now you know enough about inference that you can probably assume what those values mean. So remember, we're given 2 rows here. We're given what's called constant and average teacher salary. Now the constant represents our y-intercept, and this represents our x variable, whatever that is. And in Unit 2, when we looked at this computer output, we really just used these 2 values in the COEF. That stands for coefficient. So the coefficient of the constant is just the y-intercept of our least squares regression line. The coefficient of our x value is going to be the slope. So we've seen these 2 values before. We can create our least squares regression line with them, right? Where y hat equals negative 3,679.132 plus 0.421x. That is the equation of our sample regression line. But now we know more about what these other columns are going to stand for. So SECOEF, that stands for, what do you think? Standard error of our coefficient. So this value is the standard error of our y-intercept, and this value is our standard error of our slope. And we know now our standard error of slope is SE sub B, which we use in both our confidence intervals and our significance test. Now the standard error of our slope, standard error of our y-intercept, we are not going to use in AP statistics, so don't worry about that print off. Okay. Now T and P, you can probably figure out what those stand for now. T is our t-test statistic, and P is our P value. Now, again, for our y-intercept, we're not going to use these 2 values. We don't do inference for a y-intercept in this class. Of course, you can do it, but we don't do it in this class. But we are going to use these 2 values here. Okay? So our t-test statistic, we know, is calculated by taking B divided by the standard error of B. So if we took our slope divided by SE sub B, we get this value right here, our t-test statistic. And then we know we can use our calculator to get our p-value from that, right, in the direction of our alternative. But our p-value, when we're given information in this form, this p-value right here is for a 2-sided hypotheses test. It is always the p-value for when you have 2 sides. So if you wanted to find one side, like beta greater than 0, you would have to take this p-value and divide it by 2. Or if you wanted beta less than 0, divide it by 2, and that gives you the p-value. Okay. Here, because t would be positive, we would assume we're looking at a positive linear relationship, so we would divide by 2 if our alternative was beta greater than 0. Okay. And then these last 2 values are given down here. S stands for the standard deviation of residuals, and that's used in part to calculate this value here. And then R squared is our coefficient of determination. And remember, we can take the square root of that, so like square root of 0.468, And that's going to give us R. That gives us our correlation, which we don't use correlation in our confidence intervals or hypotheses test, but we do need to know how to calculate correlation from that computer output. Okay. So a lot of the times, especially on the multiple choice problems, you're given a computer output and you're asked a question. So like this, it says a study attempted to establish a linear relationship between IQ score and musical aptitude. Okay. The following table is a partial printout of the regression analysis and based on a sample of 20 individuals. What is the 99% confidence interval for the slope of the regression line, and does it suggest a linear relationship? Okay. So the 99% confidence interval, what do we need to do? Well, we take our point estimate plus or minus our critical value times our standard error. So we have the formula there, and we can find all of these pieces with the information we are given. We do have to calculate t-star. Our computer print-off does not give us t-star. Remember, none of these are our t-star values. Those are our t-test statistics. Okay, t-star we still have to calculate using inverse t. So 99% confidence interval with 18 degrees of freedom. This is going to be our tail probability with 18 degrees of freedom. So remember, just real quick, because I know we sometimes struggle with this. This means that 99% confidence interval, which means that 0.5% is in each of these tails, right? Because 0.5 plus 0.5 is 1%, and then 99 plus 1 is 100. Okay, so 0.5%, which remember is 0.005 as a number. And that's going to give us our negative t-star value. And I just make that positive. So 2.88, I'm going to round. 2.88 is going to be our t-star value. Okay. And then B and SE sub B, where do I get those? B is going to be the COF of IQ. Okay. And our SE sub B is going to be right here. So I put B plus or minus my t-star times my SE sub B. Okay. I get 0.35 as my margin of error. And I can create my confidence interval for this by taking 0.4925 minus 0.35 to get this value, and then add it to get this value. Okay. Now, you need to be able to interpret this. Okay. Remember that this calculates a confidence interval that attempts to capture the true population slope. It does not suggest anything about correlation or anything about strength of the linear relationship. We are just attempting to find the slope. Now, because this interval does not contain a potential slope of 0, and a slope of 0 would indicate no relationship, this interval, in fact, does suggest a linear relationship. In fact, it does a little bit more than that. It suggests a positive linear relationship between a person's IQ score and their musical aptitude, okay? Meaning their musical, ability or their draw to music. I'm not sure exactly how they measured it in this study, but there's a positive linear relationship because this interval does not contain 0. Okay? But again, it's just that there's a positive relationship. Nothing about, hey, it's strong. This isn't trying to capture R, which does communicate strength of a linear relationship. It doesn't do any of that. It just says like, hey, there's a positive linear relationship. Okay, so that's our computer output, and we'll practice that a little bit more in the homework as well. I want to talk about your TI-84 calculator commands. So both of these inference procedures, both the interval and the test, can be found under stat test, and they're way at the bottom. The t interval for a slope is the lin reg t int, and it's going to ask you for you to enter data into list 1 and list 2 and communicate your x list and your y list. Frequency is going to be 1. Your confidence level is going to be a decimal. And in this class, you're going to leave the reg equation, just leave it blank. But what it does is it allows you to put down a function where if you want the regression equation to be displayed on it, let's say a scatter plot, then you would say, hey, I want to store the reg equation in Y1. And then when you go to do a stat plot, it would show up on your scatter plot. So we're not going to use that in this class, so just leave it blank. The t-test for slope, again, asks for your x list and your y list. So it's only going to ask for data. So you can only run these on your calculator when you have the raw data for it, okay? Enter it in your list. Your frequency is still going to be 1. Now, you highlight your alternative, whether your alternative is not equal to 0, less than 0, or greater than or equal to 0. That's the only way your calculator can run a t-test. It does not run it for any other values of the slope. You'll also see it says beta and rho. Okay, so this rho stands for the population correlation, which we do not use in AP statistics. So just kind of ignore that right there. We are strictly looking at beta for our t-test. And again, the reg equation, you can just leave it blank. So let's do an example of what this looks like, okay? So let's say a random sample of 10 high school students produced the following results for the number of television hours watched per week and their GPA. Okay? So determine the least squares regression line and give a 95% confidence interval estimate for the true slope. Assume all conditions have been checked and met. I love that sentence, right? Assume all conditions have been checked and met. It's like the perfect little, okay, I don't have to check it, you know? So TV hours and GPA. We're going to put TV hours into list 1 and GPA into list 2. So if you want to go ahead and do that, fill that in. Then when we go to run our lin reg t interval, we go to stat test down to letter G. And this is the data we're going to fill in. Our X list is L1, that represents TV hours. Y list is L2, our GPA. Frequency 1, confidence interval, we want a 95%. Leave the reg equation blank. I'm going to calculate. And I'm going to get a lot of values that pop up for this. So what you'll see is a template for your regression equation. It says y equals a plus bx. And that's saying, hey, this b value and this a value that I have, A represents the y-intercept and B represents the slope since it's the coefficient of x. So that's why you're given that template right off the bat. Okay. This right here is your confidence interval. Okay. So you can see that it's negative and that your B, this is your point estimate, is going to be right in the middle of these two boundaries. Okay. Your degrees of freedom are 8 because you had 10 high school students. Degrees of freedom is going to be 8. S represents the standard deviation of your residuals. And then it does give you information about R squared and R. Okay. Now, it wanted us to determine the least squares regression line and then a 95% confidence interval. So we would just report what we have on our calculator, right? So we have our y hat equal to 3.89, which was our A value, our y-intercept, minus 0.072 and a 95% confidence interval right here. Okay. So that suggests a negative linear relationship between TV hours and GPA, meaning as TV hours increase, the more TV you watch per week, the lower your GPA is going to be. Okay. And it just suggests a negative relationship. Nothing about the strength of it. The last piece, part B here, is to define our hypotheses for a significance test to determine if there's a relationship between hours of television watched per week and a student's GPA. Use your calculator to find your p-value and explain how the results are supported by your confidence interval above. So first we have to define our hypotheses. Okay, so if we're just looking for a relationship, we have our null and alternative there as not equal to 0. Now, of course, we saw in our confidence interval in part A that there is a suggested negative relationship, but that's not what the problem here is asking, right? It just wants to know if there is a relationship. So please remember that we do have to be careful of that, okay? So our lin reg t-test, again, we have all of our x and y values already in our list. So we put that in our lin reg t-test. Our null is not our alternative is not equal to, so we have that highlighted. Okay, I fill all of that in. Not too much I have to fill in there, but I am given a lot of information back. Okay, so what you'll see, again, is this template. So my A and my B value, it gives me my least squares regression line, which is the same as what I got in A. Okay, I'm given my t-test statistic, and I'm given my p-value. You can see that it's a very small p-value. Degrees of freedom, standard deviation of my residuals here. If I were to scroll down, I also get my coefficient of determination and my correlation as well. Okay? But what can I do to interpret this? So I got these values, but what do they mean? Right? Well, we get a t-test statistic of negative 9.98 and a p-value that is very small. Okay, this is technically 8.6. And then this e to the negative 6 means that that's times 10 to the negative 6, right? So very, very small. And because our p-value is so low, we can reject the null hypotheses in favor of our alternative, which means that there is a relationship between the number of hours of TV watched per week and a student's GPA. Okay. Now, even though our p-value is very low, remember that we still can't say anything about the strength of this linear relationship, okay? Just that there exists a relationship, nothing about the strength, okay? The confidence interval in part A did not include 0, which supports this conclusion, right? Because if our confidence interval does not include our null, that means that our null is not a suspected parameter value, and therefore we can reject. In this case, we would reject at the 5% significance level for a two-sided test. Now, the confidence interval always gives us more information because the confidence interval was negative, suggesting that the more hours of TV a student watches, the lower their GPA would be. It suggests a negative relationship between those two values. A t-test, a significance test, doesn't tell us that, especially the way we set it up because it's not equal to. It doesn't tell us anything about positive or negative. So make sure not to draw those conclusions based on that sample data. You can draw those conclusions based on the interval, but you would not be able to draw those conclusions just based on this significance test alone. And that wraps up Notes 3, talking about computer output and TI-84 calculator commands. This is not only the last video in our series on Unit 9, but also the last video in our entire course of AP Statistics. I appreciate you guys following along with me every step of the way and trusting me to teach you the content of AP Statistics. Thank you so much for watching, and I look forward to seeing you in future videos. Until then, I wish you endless statistical success, and I hope you have a great day.